Chemistry video lesson. How to solve a limiting reactant problem. Limiting reactant problems can be hard to solve if you don't follow the correct steps. However, they are fairly easy if you follow the rules. Do not take any shortcuts, and especially do not write down the units, because that's the first way you're going to get into trouble with these things. A limiting reactant problem is just like following a recipe to make your cookie, your favorite. Okay? Any cookie recipe has a certain amount of ingredients, and you have to know how many of those ingredients you have to be able to make a full batch. Let's say your favorite cookie recipe is chocolate chip. The recipe says to make 2 dozen cookies, you'll need 3 cups of flour. So you gather all your ingredients, your eggs, your chocolate chips, your flour, your sugar, and whatnot, and when you get everything together, you find you only have 2 cups of flour. Well, this flour is going to limit the amount of cookies you can make. In chemistry, we call this a limiting reactant, because just like in a recipe you have ingredients, in chemistry we call those reactants to be able to make our products. Our products would be just like making these cookies. Okay? So in a limiting reactant problem, you'll always be able to tell because you've been given the amount of both ingredients. When you see that, you know you have a limiting reactant problem, and you've got to figure out how to figure out which one's going to run out first. So here are the steps. Let's practice with a little problem. Let's say we have 131 grams of iron metal, and we're going to drop it into a beaker containing 250 grams of aqueous, which means solution, of copper 2 sulfate. I want to know how much iron 3 sulfate can be produced. So number one, we have to create a balanced chemical equation. So it says we're going to take copper 2 sulfate, so let me put down my copper sulfate. Sulfate has a -2 charge, copper has a +2 charge because it tells me right there it's copper 2 plus 2. Okay, I'm going to add iron, and it's going to create, as it says there, iron 3. So this has a 3+ charge. We know that sulfate has a 2- charge. So as always, we take the 2 from the sulfate, put down here, put the 3 over here, and then of course we got copper metal left over. So now we got to balance that problem. We take a look and we start with our metals first. Both coppers are fine. Iron, which is a metal here, but I got 2 over here, so I got to put a 2 here. Now I've got all my metals done, so now I go to my non-metals. Here I have a sulfate, but over here I have 3 sulfates. I got to put a 3 over here to make 3 sulfates here on my reactant side, and 3 sulfates on my product side. But now all of a sudden I have 3 coppers, but here I only have 1 copper, so I got to put 3 over here. So now when I come back and check, I see 3 coppers, 3 coppers. I see 2 irons, 2 irons. And I see, okay, 3 sulfates, because this 3 goes to this over here, so there's 3 sulfates. There's 3 sulfates. So there's my balanced chemical equation. So now I can start my problem. Now, first thing I need to do is I take the amount from my problem and they gave me, okay? So it says I have 131 grams of iron. Well, I need to turn that into moles. So then I would multiply this by 1 mole of iron. We can look at the periodic table and see that's 55.85 grams. Okay? So when we do our math on that, and let me hit the calculator here, it says that we're going to end up with 2.34 moles of iron. Okay, is what I got. Now I got to do the same thing for my 250 grams. So I do my math, and I figure out that copper 2 sulfate, 1 mole of copper 2 sulfate, okay, weighs 159. What did I have? 45. That's according to my calculator, 45 grams. So when I do my math, 250 divided by 155, I get 1.57 moles of copper 2 sulfate. So step 1 or step 2 is, create grams to moles. Step 1 was our balanced equation. Step 2, grams to moles of both my reactants. Now I know both my reactants how many moles I have. Now I got to figure out which one of these is going to run out first. Which one is going to limit my reaction? As we look over here, we say we ended up with 2.31 moles of iron and 1.57 moles of copper 2 sulfate. So what I usually like to do is I will take, and let's, take the first one out of our balanced chemical equation, which, remember, we had 3 copper 2 sulfate plus 2 iron created 1 iron 2 sulfate plus 3 coppers. Now that was our balanced chemical equation. I like to usually take the first one and I use that. So I'm going to take my 1.57 moles here of that. So I take 1.57 moles of my copper sulfate, and I want to then determine how much iron I'm going to have. So I need to work this with my balanced chemical equation at the mole ratio, because this tells me it needs 3 moles of this plus 2 moles of this will create 1 mole of this. And then, of course, 3 moles of my copper left over. So this is a 2 to 3 ratio. Okay? It's a 3, excuse me, not a 2. So I take 1.57 times 2 divided by 3 means I need 1.05 moles of iron. Okay? This is how much I need to use up all of this. Okay? So to use up all of this copper 2 sulfate, I'm going to need 1.05 moles of iron. I look up and I see, well, how much do I have? Well, I have 2.31. That means I got more iron, or I have excess iron for my problem, my reaction here. So that means that right off the bat, I can tell that my copper 2 sulfate is my limiting reactant. It's going to run out before I run out of iron. So we have figured out that my limiting reactant is 1.57. Now, once we figured that out, this is the only reactant I can use to determine how much product I can make. Okay, I can't use anything else. Now, by taking my excess iron, and if they ask you in a problem, and sometimes they will, how much excess do you have left over? Well, then you would want to end up, and we could take our amount of 2.31 minus 1.05, and I think this should have been actually 2.35 instead of 2.31. Instead of, and then all we do is take that. So I'd take 2.35 moles of iron minus 1.05 is how much I'm going to use in my reaction, because that's what we determined, okay, because that's all I need. And that's going to leave me with about, let's see, 1.30 moles. So I would end up with this many moles left, and if they wanted me to turn that into grams, then I would have to multiply that by 55.85 grams of iron, just like we did before, moles to grams or grams to mole. So the amount of excess I have left over is 1.3 moles of iron is what I have left over here. If they ask me now to figure out how much product I can make, I can only use what I have up here, because that's my limiting reaction. Okay, so we take a look again at our balanced chemical equation. We take our 1.57 moles of my copper sulfate. We use our balanced chemical equation. Now we're trying to figure out this. So that's 1 mole of my iron nitrate, 3 nitrate to be honest with you. And that's to 3 moles of my copper 2 sulfate. Moles of copper 2 sulfate, both sides cross cancel. 1.57 times 1 is 1.57. 1.57 divided by 3 is going to give me 0.52 moles of my iron 3 sulfate here that I'm going to make. So I'm going to make 0.52 moles. And if I needed to figure out if they told me in grams, I'd take my 0.52 moles, and then we know by adding all of this up, 2 irons and 3 sulfurs and 12 oxygens, that we know that it's 399.7 grams in 1 mole. Okay? So if we multiply that out, we're going to equal about 209 0.18 grams is how much product we're going to make. All right. So that's how we end up figuring this out. First, we had to figure out which one was going to run out first. Once we figure that out, then it just becomes a regular, okay, like anything else. So you can always tell when you have a limiting reactant problem, because as I said before, you're going to get both reactants right off the bat. They're going to give it to you in either grams and moles. The rules we talked about are very simple. Number one, create a balanced chemical equation. Number two, turn the mass of each reactant you're given into moles. Now those are the same things you do on any problem. Number three here is the only one that you do that's different. And that's where we're going to compare the reactant of 1 mole, one reactant, we compare with the other one. And the one we have excess amount becomes our excess reactant, and the one that we don't have enough of and is going to run out becomes our limiting reactant, and our limiting reactant is the only one I can use to determine how many products I can actually make. Now, you need to review this video as many times as possible so you can really develop this skill. And the other thing is as you're going through this, if you come up with any questions, or if I've made a mistake and you say, I'm not sure of this number, bring them to class and ask them. I can guarantee you there are other students that have the same exact question. Remember, as always, chem is try. Keep trying and never, ever, ever give up. Stay gritty out there.